Hello guys, welcome to my YouTube channel. So today we are going to discuss another important problem which came in GATE 2023, and this problem is basically falls on the under the topic of recombinant DNA technology, RDT, or some people call this topic as genetic engineering. So whichever way you go by it, and more specifically this is actually a problem of PCR. So in the lab when you perform PCR, I think you know that you have to do some calculations regarding the preparation of the master mix or preparation of the restriction enzymes or the preparation of the quantities of the forward and reverse primers. So basically, if you know the basic calculations, laboratory calculations, then these kinds of problems will be easier for you. Still, I will explain. So what the problem states is that dNTP master mix. dNTP master mix means it is a mixture of various dNTPs, deoxy nucleotide triphosphates, and is prepared by combining 40 microliter of each 20 millimolar dNTP stock. So you have a dNTP stock, and this dNTP stock contains each of the four types of nucleotide triphosphates, deoxynucleotide triphosphates, dATP, dCTP, dGTP and dATP, and the concentration of the dNTP stock is 20 millimolar, and from this concentration you are taking 40 microliter of each dNTP stock to prepare a final volume of the dNTP stock, dNTP master mix, and from this final volume you are taking 4 microliter again. So basically if I draw here is that this is the dNTP stock. Okay, this is the dNTP stock, and the concentration of this dNTP stock is 20 millimolar. Okay, and in this dNTP stock you have the four kinds of dNTPs. From this dNTP stock, so this is basically what? This is your stock solution. This is your stock solution, and from this dNTP stock solution you are taking 40 microliter of each dNTP stock. Okay, 40 microliter of each dNTP stock, and you are preparing the dNTP master mix. So this is what? This is your dNTP master mix. I write the master mix as mm. Okay, now from this dNTP master mix you take 4 microliter. Okay, and you put it in the PCR tube, and you add all the necessary restriction enzymes, forward, reverse primer, your template, everything. So this is what the problem actually is. So if we read the question carefully, then the initial volume for you will be the volume that you are adding to this PCR tube, because this is the volume that is going into the PCR. So this will be your initial volume. So the final the initial concentration S1 will be 20 millimolar, or if you convert it to molar concentration, then it will be 20 into 10 to the power of -6. Okay, and the final volume is already given to you, which is 50 microliter. So the final volume after adding all the components should be 50 microliter. So what should be the final concentration of all the total dNTP? So you have to find S2. Okay, so this is the problem. So what will we use? We will use here the concept of V1S1 equal to V2S2. So we have V1, we have S1, we have V2. We just need to calculate S2. Okay. So now we are adding these are the things that are being given to us. 4 microliter of each dNTP master mix was added. Final volume is adjusted to 50 microliter. So these are our V1 S1 V2 S2. So if we calculate it in liters, then 4 microliter becomes 4 into 10 to the power of minus 6 liter multiplied by 20 to the power of minus 3 molar. So this is our V1. Okay, this is our S1, this is our V2, because they have said the final volume should be 50 microliter or 50 10 to the power minus 6 liter multiplied by S2. So this will be our final concentration. So we'll calculate S2, which comes out to be approximately 1.6 10 to the power of minus 3 molar. If you want the answer to be in micromolar, because they have said the final concentration to be in micromolar, so it comes out to be 1600 micromolar approximately. So this is a problem. We will discuss more such problems in our subsequent lectures.